In my last videos, permutations and combinations part 1 and part 2, we have seen how to find permutations when all the objects are distinct or different, in which we have seen the formula for number of permutations of n objects taken r at a time when the objects do not repeat is npr, which is n factorial upon n minus r factorial, and the number of permutations of n objects taken n at a time when the objects do not repeat is n factorial, and number of permutations of n objects taken r at a time when the objects do repeat is n raised to r. In this video, we are going to study how to find permutations when all the objects are not distinct objects, or finding number of permutations when some of the objects are of the same kind. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. We have to find how many four-letter words we can make from the letters of the word root. We observe that these two O's are of the same kind. We can either treat them as two separate O's, O1 and O2, and find the number of words that can be formed. In this case, we have four vacant places. First can be filled in four different ways, second in three different ways, third in two different ways, and fourth in a single ways. So the total number of words in this case will be 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 4 factorial 24. Or we can consider these two O's together to be a single letter, and we will have three places to be filled. The first can be filled in three different ways, the second in two different ways, and third in one different way. Now these two O's, which we have considered to be same, they can interchange between them in two factorial ways. So the total number of words will be 3 multiplied by 2 multiplied by 1 multiplied by this 2 factorial. That will be 3 factorial into 2 factorial, 6 multiplied by 2, 12 words. Now this in terms of this 4 factorial can be written as 4 factorial upon this 2 factorial, which will be 4 multiplied by 3, 12. So whenever there are n objects out of which r are of the same kind, then the total number of permutations that we can make is n factorial upon r factorial. In the word Allahabad, there are 9 letters, so n is 9. 4 A's which are of the same kind, so P1 is 4, and there are 2 L's, P2, which are of same kind. So total number of permutations, total 9 letter words will be n factorial upon P1 factorial into P2 factorial, which is 9 factorial upon 4 factorial into 2 factorial, which is 9 into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial into 2, which is 2 factorial. Cancelling 4 factorial, 2 ones are, 2 fours are. So the product of 9, 4, 7, 6 and 5 will be 7560. So this will be the total 9 letter words formed, 7560. To 2, 4 factorial gets cancelled, 4 twos are 8 gets cancelled, 3 twos are 6 gets cancelled, and the product of 11, 10, 9, 7 and 5 will be 34,650. These are the permutations when the i's were not together. But we have to find out the permutations when these 4 i's do not come together. So first we will find out permutations when 4 i's are together. We will consider set of 4 i's together to be one single letter plus 11 minus 4 i's, that is 7 letters. So the total letters to be arranged will be 8. Now we have these 8 objects with 4 s's and 2 p's. So these permutations of 4 i's together will be equal to this 8 factorial upon this 4 factorial into this 2 factorial, which will be 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial upon 4 factorial into 2 factorial. Cancelling 4 factorial, 2 ones are, 2 fours are, and the product of 4 multiplied by 7 multiplied by 6 multiplied by 5 will be 840. Now the permutations when 4 i's do not come together will be equal to all distinct permutations, which is 34,650 minus number of permutations of 4 i's together, which is 840. This subtraction gives 33,810 words. How many words with or without meaning can be formed using all the letters of the word equation at a time so that the vowels and consonants occur together? There are 5 vowels A, E, I, O and U, which can be arranged amongst themselves in 5 factorial ways. There are 3 consonants Q, T and N, which can be arranged between themselves in 3 factorial ways, and one group of vowels and one group of consonants will form 2 groups which can arrange between themselves in 2 factorial ways. So considering all this, total words satisfying the conditions that vowels and consonants occur together will be 5 factorial into 3 factorial into 2 factorial, which works out to be 1440 words. How many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7 and 9, which are divisible by 10 and no digit is repeated? In a 6-digit number, there will be 6 vacant places. Since the number should be divisible by 10, there will be always 0 in this units place. And since no digit is to be repeated, these remaining 5 places can be filled in 5 p5 ways multiplied by this single place 0, that will be 5 factorial. So 120 6-digit numbers can be formed according to this condition. We have to find how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated. From 3-digit numbers, we have r equals 3. From 1 to 9, we have n equals 9. And since no digit is repeated, total numbers will be npr 9p3, 9 factorial upon 9 minus 3 factorial, 6 factorial, 9 multiplied by 8 multiplied by 7 multiplied by 6 factorial upon 6 factorial, cancelling 6 factorial. These total numbers will be 504. We have to find how many 4-digit numbers are there with no digit repeated. These 4-digit numbers will be formed from digits 0 to 9, so n will be 10. We have to fill 4 vacant places. This first place should be non-zero, so omitting 0 from 10 digits, this first place can be filled in 9 different ways. Now we are left with 10 minus 1, that is 9 digits. Second place can be filled in 9 different ways. Now we have 10 minus 2, 8 digits. Third place can be filled in 8 different ways. Now we have 10 minus 3, 7 digits left. So this fourth place can be filled in 7 different ways. So total numbers formed will be 9 multiplied by 9 multiplied by 8 multiplied by 7, which can be written as 9 multiplied by 9p3, which is 9 multiplied by 9 factorial upon 9 minus 3 factorial, that is 6 factorial. So the total 4-digit numbers formed will be this product, which is 4536. We have to find 3-digit even numbers from the digits 1, 2, 3, 4, 6, 7. If no digit is to be repeated for a 3-digit number, we have to fill 3 vacant places. Units place must be filled with either 2, 4 or 6. That means in 3 different ways. Now we are left with 6 minus one of the digits filled in the units place 1, 5 digits. We have to fill the 100th and 10th place, that is 2 places, using these 5 digits. So the 100th place can be filled in 5 different ways, and 10th place in 5 minus 1, that is 4 different ways. So in short, these 2 places will be filled in 5 P2 ways, 5 and 2, and this units place in 3 different ways. So multiplication of these two will give us the number of 3-digit even numbers that will be formed by this arrangement. So total numbers formed will be 5p2 multiplied by 3, 5 factorial upon 5 minus 2, 3 factorial multiplied by 3, which is 5 multiplied by 4 multiplied by 3. 60 different 3-digit numbers which are even. From a committee of 8 persons, in how many ways we can choose a chairman and a vice chairman, assuming one person cannot hold more than one position. That means one person, one position. For 8 persons, we have n equals 8, and out of these 8 persons, we have to fill 2 positions, one for chairman, another for vice chairman. So we have 2 vacant places, one for chairman and one for vice chairman. The first place can be filled in 8 different ways, and the second in 8 minus 1, that is 7 different ways, because no 2 persons can hold the same position. This in short will be 8p2, that will be 8 factorial upon 8 minus 2, 6 factorial, which again will be same as product of this 8 and 7, 56. So in 56 different ways, from a committee of 8 persons, a chairman and a vice chairman can be chosen. How many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once? That means there is no repetition. Here there are 8 letters in the word equation and all are different. So n is 8. Since we have to use all 8 letters to form the words and each letter comes exactly once, total number of such words will be 8p8 or 8 factorial, which will be 40,320 words. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated? If number 1, 4 letters are used at a time, which means R is 4, and there are 6 distinct letters in the word Monday, so n is 6. So the number of words formed will be 6p4, 6 factorial upon 6 minus 4 factorial, 2 factorial, which is 6 multiplied by 5 multiplied by 4 multiplied by 3, that will be 360. Number 2, all letters are used at a time, which means R equals n equals 6. So number of words formed will be 6p6, 6 factorial, 720 words. Number 3, all letters are used, but the first letter is a vowel. 6 vacant places are to be filled. There are 2 vowels in the word Monday, O and A. So the first place will be filled in 2 different ways. Second, in 6 minus 1, 5 different ways. Third, 4 different ways. Fourth, 3 different ways. Fifth, 2 different ways. And sixth place in 1 different way. So the total number of words formed will be this 2 multiplied by 5p5, which is 2 multiplied by 5 factorial. So total 240 words. In how many ways can the letters of the word permutations be arranged if number 1 the words start with P and end with S? We have total number of letters in the word permutations. N is 12. Since the words start with P and end with S, letters to be arranged, say N1 equals 12 minus 2, 10. There are two T's, say R1, which are of the same kind, and they can interchange between them in 2 factorial ways. So total such words will be this 10 factorial upon this 2 factorial, which will be 10 multiplied by 9 multiplied by 8 multiplied by so on and so forth multiplied by 3 multiplied by 2 factorial upon 2 factorial, cancelling 2 factorial. This will be 1814400. Number 2. If vowels are all together, there are all 5 vowels present, A, E, I, O and U, and each is coming once. We will consider set of vowels A, E, I, O, U to be a single letter 1 plus 12 minus these 5 vowels, which is 7. So it will be 8. So now we have to arrange these 8 letters, and as usual there are 2 T's to be arranged in 2 factorial ways. So these 8 letters with 2 T's will form words equal to 8 factorial upon 2 T's of same kind, that means 2 factorial, multiplied by these 5 vowels, which will interchange between themselves in 5 factorial ways. So this total calculation will work out to be 2419200. And third, if there are always 4 letters between P and S, this is composed of 2 parts. In the first part, it starts with P and ends with P, that is between P and S. So it will be same as 10 factorial upon 2 factorial. Next, it is said that always 4 letters between P and S. So multiplied by these 2 letters multiplied by, we consider set of these 2 letters P and S to be a single letter, that is one letter, plus the 4 letters which are going to come between them, which will be 5, and 12 minus 5 is 7. So here we have to multiply by 7. So these many words will have always 4 letters between P and S, and this calculation works out to be 25401600. If you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.